Hi there, this is the second test in the 16-part carbon test. This time the cells are wrapped in a separator totally around the carbon cell and submerged in a tub of electrolyte, which is Epsom Salts, the same solution, but this time they're just submerged. And cell A, which is the banana skins, black snake sugar cell. Its native voltage is 0.77 in the solution, and a short circuit on it. Left meter is milliamps, set on the 200 range. Short circuiting cell A, and we had 2.7, I think it was, before charge. 2.7. Alright, as the other videos, I'll give it a minute's charge and I'll get back. Okay, cell A is coming up to a minute. We've hit a minute now. The voltage should bounce down a bit. 2.7 for the voltage. A short circuit after a charge. 59 milliamps. Not bad. 59 milliamps. Holding 17.5. Going up 18 milliamps. Voltage is down, but seems to be an improvement. On the first test, the cell generated 13 milliamps on a short, so we exceeded that by a bit just by submerging it in the tub. Alright, we'll watch the voltage recovery. We started at 0.77, we're at 1 volt, not too bad. That's black snake sugar carbon, cell A. I'll give it another short and see what's left. 8 milliamps, not too bad. Well, the next cell is the mystery cell B. Cell B, its voltage before charge 0.8. Its short circuit is 3 milliamps, and I'll give it 1 minute's charge. Coming up to a minute's charge on cell B, and 1 minute. And we have 2.6 volts. I was counting 10 milliseconds since I disconnected the lead. And for a short circuit on cell B, 40 milliamps. And it's holding 11.8. The cell A was up on that one, and it also had 0.5 on cell A, if I remember correct. The next cell is the derivative from the carbon of cell B. It's a resin. So I'll connect cell C and I'll get back. Okay, we have cell C connected. Its voltage is 0.6. Its short circuit before a charge 0.5. Not going to go up. At 0.5. See if the voltage bounce up decently. We had 0.6. Voltage is sort of there. Alright, I'll give this one a minute's charge and I'll be back. Okay, we're coming up to a minute's charge on cell C, and 1 minute. And 2.4 volts. and a short circuit on this one, 30 milliamps. And dropping fast. Oh yeah, looks like it's going to hold 6.8 milliamps. I think that's an improvement on the first test. And the voltage recovery. We started on 0.6 before a charge. See if we get to the 1. Yeah, we got to the 1 volt. Yeah, probably not going to go much up. And a short circuit, 5 milliamps, holding 4.3. Yeah, not too bad. The next cell is the graphic carbon nitride, cell D. Cell D is connected. Its native voltage is 0.88 and its short circuit 2.5 milliamps. And it recovers 0.7, not bad recovery. Alright, I'll give it 1 minute's charge. Coming up to a minute's charge on cell D. Cell D seems to be making a lot more bubbles than the other 3 cells did on the same charge. Oh, 1 minute. .7 on the 10-second countdown. And for a short circuit on cell D, 67 milliamps. That's not too bad. And holding 33.5. Oh, now we're dropping. Voltage is tiny bit up, but dropping a bit. Still delivering 23 milliamps. Not too bad. That's the graphic carbon nitride cell. They perform a bit different in their cell in liquid tubs. Electrolyte must have really gotten into the carbon now. And for a recovery, we started off at 0.88 before a charge. And we're recovering not too bad, probably go to 1.3. Well, we might go to 1.5 on this, it's slowing down. Probably 1.4. Alright, the next cell is cell E, the banana skin ash, which proves interesting in some of the other experiments. Okay, I'll connect that. Cell E, its native voltage is 0.82. It's banana skin ash for a short circuit. It's delivering 1.5 milliamps and dropping. And voltage has dropped right off. And I'll give it a minute's charge and get back. Cell E is coming up to a minute's charge. Its voltage is slightly lower. Okay, 1 minute. And 2.5 for this one. And a short circuit on cell E. 34, 38, 50, 60. What's going on here? 70 milliamps. That was weird. Must be some sort of bottleneck going on. Didn't bubble as much as cell D did, but it was a bit more than the other cells in its loading. And this cell is banana skin ash, and it's holding, no it's not, it's dropping. Its voltage is still up compared to the first tests. And at recovery, we started off at 0.8. That's our starting voltage before charge. And what, we're probably going to go to 1 on this one, just over 1.2 probably. And for another short circuit, 7 milliamps, oh 8, 9, 10 milliamps. That's got, yeah, must have trouble getting electrons flowing, or ions perhaps. Alright, the next cell is cell F, banana skin, which didn't turn into ash. Okay, back with cell F, its native voltage is 0.78. And its short circuit before a charge, 6.9 milliamps. And dropping pretty good. Bit of a voltage bounce back. Yeah, alright, so I'll give cell F a 1 minute's charge and I'll be back. Coming up to a minute's charge on cell F, voltage is going back up on this one. And 1 minute. And this one's 2.2 volts after 10-second delay. I was just counting it. Alright, short circuit. Short circuiting now. 56 milliamps. Banana skin. The other one performed a bit better this time. Banana skin ash. Voltage was a bit higher. Except for the initial milliamps, we got 6.9. And voltage recovery, we're holding 9 milliamps. And voltage recovery, we started off at 0.78 volts. This one's probably going to go up to about 1.2. Alright, so the next cell is the graphene cell, cell G. I'll set it up. Okay, cell G is good. 1.08 volts. And its short circuit, 13 milliamps. 13 milliamps. That's not too bad. And I'll give it a minute's charge and see what we get. Voltage did drop. Oh, it's going back up to 0.8. I'll give it a charge and be back. Up to a minute's charge on the graphene one. It's turned all milky. It's doing fine bubbles or something else. And that's a minute's charge. And 2.6 we had for its voltage after 10 seconds. And for a short circuit, 105 milliamps. Why? 105 milliamps. That's not too bad. Holding its voltage, sort of. If you call that holding its voltage compared to the others it is. Milliamps are up, 36, 37. Strange behaviour going on. It's counting up and holding. Now it's dropping. Must be a bottleneck. Could be resistance in the alligator clips are a bit rusted now. And for oh look, we're still at 31 milliamps. So that could be possibly graphene. It's better than the graphite one, which we'll find out next. Cell is H. and the voltage is finally going down. Same with the milliamps. We'll check the rebound. So far that's got the highest milliamps on a short circuit after a charge out of the whole lot. And the voltage is going good. We'll give it another short, see what's left. 12 milliamps. Alright, so I'll load up the other cells and I'll be back. Okay, cell H has a starting voltage of 1. That's not too bad, that's like the other one, the graphene one. And initial short circuit on it, 3.9. That's down, the other one had 13 milliamps for some reason. Alright, I'll give it a minute's charge and I'll be back. Okay, cell H is coming up to a minute and voltage is a bit lower and not too many bubbles are coming out the top compared to the other cells. And 2.5 volts for this one. And a short circuiting now, 41 milliamps. Not too bad. We're a bit high up here. Got 20 milliamps, that's the graphene one. Compared to the, that's the graphite one. The graphene one had 105 milliamps in a short compared to 41. And slightly up on the voltage. Hard to tell. And for a rebound, rebounding not too bad. We started off at 1 volt, it's going to 1.3, probably go to 5. It's at 4 maybe. It'd probably head up to 5. And what's left? Another short circuit, 9 milliamps. The next cell is cell I, is activated black snake carbon. Alright, I'll be back. Cell I has a starting voltage of 0.78. It's activated black snake sugar carbon and it's short circuit. 2 milliamps. A bit of a rebound. It's rebounded back to where it was after a short. I'll give it a minute's charge. Up to a minute. Some of the other cells are at 5 volts by now, but that's 1 minute. And 2.4 voltage, and for a short circuit 45 milliamps. That's a bit better than cell H, and we're holding 16, oh we're counting up again, 19 milliamps. I don't know why it does that, strange. And then drops down. Wonder, I'm shaking the leads and nothing's doing that. Alright, the next, we'll do a voltage rebound. We started off at 0.78. This is the activated black snake sugar carbon material. And we're up at 1.2. Yeah, not too bad. The next cell is the banana flesh cell, cell J. Okay, cell J, voltage, starting voltage is 0.88. Its initial short circuit value, 3.8 milliamps. and I'll give it a minute's charge again. Coming up to a minute on cell J for its charge. Hasn't hit the 5 volts yet. It's bubbling a lot more than the other cell, and we're at a minute. And 2.5 volts. And on a short circuiting now, 37.8 milliamps. And counting down, 25 milliamps. It's dropping. It's holding its milliamps a bit though, better. And that was banana flesh. Oh, the next one's potato skin, cell K. That performed okay in the first test. So we'll do a rebound of the voltage. We started at 0.88 for this cell. We're up at 1.2. This one might go back to 1.5 maybe. Nah, she's slowing down. Probably 1.4 would be the highest on that one. So I'll set up cell K potato skin. Cell K potato skin, slightly higher on the voltage, 0.91. And for a short circuit, 10.8 milliamps. Oh, that's not too bad. That's one of the higher ones. The other high one was cell G, the graphene one, which was 13 milliamps. Well, alright, I'll give it a minute's charge. Coming up to a minute's charge on cell K. Its voltage hasn't got to the other voltage, it's down. That's 1 minute. And 2.3. Its voltage is down on that. That's banana skin cell. And for a short circuit on cell K, 76 milliamps. It's one of those ones that's jumping around. Take the highest value, as I did with all the other cells, so keep it constant. This one's not doing too bad actually. Probably the charge time, it needs a longer charge time and probably less volts being charged. It was bubbling a bit. Bubbling's sort of still going, but not too bad. 1 or 2 bubbles. So potato skin, well, not too bad. Nothing that fancy. 76 is still good milliamps. I think that's still the second highest again. And for a voltage recovery, we're still at 19.5 milliamps, and the voltage is still up there. It should be normally 0.01. Alright, for voltage recovery, we started at 0.91, going up a bit slower, but we short-circuited longer here, and not too bad voltage recovery. The next cell is cell L, which is the activated charcoal from the shop. That one was interesting. I'm not sure if it's contaminated or not, but I'll see. Alright, 1.4 maybe on that one. Alright, cell L next. Cell L, the starting voltage is 0.96. That's higher than the last cell. It's short circuit, 11.3 milliamps. Those were high. Okay, so I'll give it a minute's charge and I'll be back. Up to a minute's charge on cell L, activated charcoal, and 1 minute. And 2.3 volts. And for a short circuiting now, 96 milliamps. Yeah, that one's got to be tainted, surely. 96 milliamps. But then again, that graphene one only had acetone in it. And that was 105. We're pretty good here. Cell L's looking alright. Activated charcoal from the shop. Has extra goodies, maybe. I still didn't read that. Supposed to be aquarium filter charcoal. We're at 51 still. This one's drawing its time. This one was producing big bubbles of gas. Bubbles were about double the size of the others. And power in that one's not too bad. Still at 0.12 and holding. Well, that one needs a little star and asterisk again. Looks like the winner. But I'll have to try that experiment again and wash that charcoal. And for a rebound, we're not going down too fast. Make the video too long. Voltage went right up really quickly. We started off at 0.9, charged up to 2.3. And this one will probably go to 2.5. It's jumping. Yep. The next cell is coffee grinds, cell M. Okay, I'll set that one up. Oh yeah, we hit to 1.5 volts on this cell. Okay, cell M, its starting volt is 0.95 and its short circuit 4 point something and holds, oh yeah, it's counting up. And this was coffee grinds, oh yeah, 4.6, 5 milliamps. Yeah, that's strange. Nothing in that coffee grind, it's just coffee grind, carbon. 8 milliamps. We'll call it starting. We could go to 10 milliamps. Yeah, we'll call that one 10 milliamps. We'll cheat. Dodge the records. Oh, that did count up. Don't know why that counted up. Just coffee grinds. Alright, for a charge. I'll be back. Coming up for 1 minute's charge. Its voltage went up over the other ones. And it seems to have faster little bubbles. Bubbles are tiny, but they're coming up fast. And that's 1 minute and 6 seconds. And 2.5 for this voltage. And a short circuit, 52. Oh, 56. What's going on? I wasn't looking. I might look at the video for this one. I saw 56, but maybe it was up. Another bizarre cell, and this one was coffee grinds. So they're definitely different in tub form, in liquid cell. Where was the coffee grinds? So on this other sheet. Yeah, 1.5 milliamps on a short before a charge, and on a charge it had 11, where we got 56 this time. And a recovery, we were at 0.95. We held this pretty long, about 1 minute 36 seconds on short circuit. And we're going to 1. The next cell is the plain base cell, so that will be interesting to see what value we get in that cell. Alright, I'll be back. Okay, cell O, our base cell, it's just got no carbons on any of the electrodes, it's just separated with a membrane, and our voltage is 0.88, and a short circuit 4.8, not too good, 4.8, but it doesn't have any carbons or anything, so you'd hope it was down. Alright, I'll give this one a minute's charge and I'll be back. Coming up to a minute's charge on our cell O, which is the base cell, standard plain old cell. And 2.8 after 10 seconds. And for a short circuit on the plain cell, 65 milliamps. Huh, gee. That's alright actually, that beat the coffee grinds. And it's also holding, coffee grinds was up still I think on the voltage. Not bad for no carbon cell, just a electrode and the other a piece of aluminium and a separator. Gosh, that performs pretty well actually. Is it because it's close or something? The two plates are closer. Maybe the plastic carbon electrode is sort of holding. Not sure. And for a recovery on this, we're still at 12 milliamps. On a voltage recovery, we were at 0.88. Oh yeah, we got 1. Probably go to 1.3 by the looks of that. And another short just to see what's left. 9 milliamps. So that's the base cell of the tests. That's a plain cell with no carbon on it. The next cell is the iron oxide plus the mystery carbon plus graphite. That performed okay in the other one. I'll just set it up. Okay. Cell P, its voltage is 0.79. It was dropping a bit. 0.79. I'll just check, could be leaking. And its initial short circuit, 2.4 milliamps. Alright, I'll give cell P a charge for a minute and I'll be back. To a minute's charge on cell P, which is iron oxide plus mystery carbon plus graphite. And that's a minute. And 2.5 for that one, and a short circuit, 56 milliamps. That's not too bad, but dropping quickly. So that one's not... I think half the cell's broken. Broke the cell putting it together. But not much, it's still holding 6 milliamps. And the next cell is cell Q, which is graphic carbon nitride plus the mystery resin carbon. Alright, I'll be back. Oh, hang on, voltage rebound on this cell. We started off at 0.79. It's moving up quite quick. This one might be a 1.5 by the looks of this. Yeah, we're really slowing down. 1.4 if we're lucky. Alright, I'll set up cell Q. Okay, cell Q is connected and its starting voltage is 0.81 and its initial short circuit 3.6. Voltage dropped right off. And I'll give this one a minute's charge and I'll be back. To a minute's charge, 1 minute's charge on Q. And we have a 2.6 after 10, count of 10. And for a short circuit, short circuiting now, 74 milliamps. That was alright actually, 74. But, oh yeah, we're holding pretty good. That's a graphic carbon nitride plus mystery carbon resin carbon stuff. And the next test after this is our cell R, which is the silica dioxide, just as a novelty. It's not even a carbon, but this one's still holding its 30 milliamps after 1 minute. Still slightly up on its voltage. And for a rebound, we started at 0.18 volts, we're at that now. Probably about 1.2 if we're lucky on that one. So I'll set up cell R and get back. Cell R, starting voltage is up, 0.92. And for a short circuit for it, 1.4 milliamps. And I'll give it a charge for 1 minute and be back. Coming up to a minute's charge on cell R. It's got a few bubbles around the outside of the aluminium plate. Oh, that's 1 minute. Low on voltage. 2.6, and for a short circuit, 48 milliamps. Not too bad. That beats some of the other ones with carbon. Oh no, does it? Yes, it does. It beats the resin one, had 30 milliamps, and it also beats the mystery base material. And that's not even a carbon. Yeah, won't mention those other carbons in. No good. And it's still holding that. And for a voltage recovery, we started off at 0.92. Probably only going to get to 0.34. And like we did last time, we'll turn up the voltage on the charger to 10 and give it 30 seconds of charge, I reckon. Alright, we're sort of settled. 1.3 volts was it. And here's a test charge at 10 volts for 30 seconds. Bubbling up pretty good. 12 seconds. 18. 23 seconds. Oh, it looks like it's going to cook in there. Should have had my lighter with me. 30 seconds. And it stayed up. The voltage is a bit higher. This time 10 seconds last time after the charge. And for a short circuit, 70 something. Oh yeah. So there you go. That's the silica dioxide cell plated on both sides, and a piece of material, piece of paper towel as a separator. So that concludes this experiment. We've got some varying results here. I'll put them up on YouTube. And thanks for watching.